In this training video, I'll illustrate cell tracking using TrackPad. After you've loaded the image stack and a track file, if it exists, you start a new track by using the mouse to right-click over the image. First of all, let's say we want to track this cell down here. We first of all zoom around the cell, and then we would like to track it over time. So this is from the beginning. You can see it divides and forms two cells. So let's track the mother cell and its two daughters. So the first thing we do is right-click, start track, move the ellipse over a feature that doesn't change. So in this case, the nucleus is the most stable feature. In fact, for most cells, the nucleus is always the most stable feature, and also a reasonable boundary around that stable feature. And here we've created an ellipse that includes a fair amount of cytoplasm. But you can change the size of this ellipse if you wanted to. You can make it smaller or bigger. So let's just make it a tidge smaller. So then once you've selected the ellipse over the cell, you double click and it'll automatically track. And you can stop it at any time by just clicking the left mouse button, or you can right click to bring up the drop down menu. You can reposition the ellipse, continue tracking, stop the track, or delete the track. So I'll just, first of all, I'll illustrate repositioning the ellipse. We can move it so it's more central. And we can continue tracking. So there are also hotkeys. So if I just type C at the keyboard, it will continue tracking. Now you can see the automatic tracking has stopped autonomously. And the reason for that is that the cell is divided and the nuclear image has changed a lot. So this tracking algorithm uses correlation, and if the correlation coefficient drops below a threshold, it'll automatically track. So, and that's quite convenient because it'll stop tracking at the end of the cell track before it dies or before the cell divides. So what we want to do is we want to track right up until the cell divides. So we use the scroll to move forward in time, and you can see we have to do a few more images. We need to track a few more images to one. So what we've done now, we've tracked a few more images, and you can see now we've gone too far, and so we might want to back up, reposition the ellipse, and then delete the remainder of the track by going delete track. And so now you can see that we've reached the end of this track. So we've tracked our first cell. Now we want to stop the track to save it. You can see it's got the green NC over it. That means the track is not completed because we haven't really annotated the track's fate. So you can see here it's got P1 TR1, that's progeny 1 track 1, and that's the actual position, the actual name of the cell in terms of what progeny it is and the track it is. So each cell will get a unique progeny and track number. Alright, so the next thing we'll do is we'll annotate this cell. We want to say that first of all it's an ancestor, and secondly that its fate is division. So we go to select track, we click on the cell or over the, and you see it's gone red. That means we've selected this track. And then we right click again and we click annotate track, and its origin, it's an ancestor, it's not a daughter cell, and its fate is division. So these are the two fundamental annotations you do for all cell tracks to create division trees, but you also have custom cell properties that you can add at a later time. So once we do that, we close this box, and it's now annotated the fate of this cell as division. So you can see now there's a DI, division over that cell. So the next thing we want to do is we want to track its daughter cells. So we start track, place this over one of the daughters, C to continue, tracks this cell. This would go faster if the ellipses were smaller and also if the resolution was lower. But sometimes it can go too fast. You can't keep up with it visually. So this cell is starting to change shape, and I might just zoom up over it to have a better, closer look what's going on. Type continue, and you can see it's going to divide. So we reposition the ellipse, and then we form two cells. So what we might do is what we did before, is reposition the ellipse and delete. So what it does, it'll delete all of the ellipses in this frame and all the future frames. Might just trim this so it's right in the middle of the division and stop the track. So now we've got a new track, and it's calling it progeny 2 track 1, but it's not really progeny, it's a daughter cell. So what we do next is we select the track and we would like to annotate that track. So we go annotate track, and now its origin is that it's a daughter, and what it'll automatically do is go to the closest tracked cell, which was progeny 1 track 1, which is a division, and if you click on that, it'll assign that as its parent. Its fate of this cell that we've just tracked is it's a division fate, and so we click on that. So now if we go through, you can see that we're going forward in time, division, daughter cell, go to the end, and we see it divides, it's a division. So that just shows you the basic steps in tracking cells. So now that we've tracked cells, we should really save them as a file, as a .mat file. So you go to File, Save Tracks. I'm just going to call this new track file and save it. So I've now tracked the two daughter cells, and you can see that there are two daughters here, and here's progeny 1 track 2, progeny 1 track 3, and we can also look at this pedigree using the pedigree navigator. So open track table, and you can see now we've got a table that shows all the tracks, their parents. So the parent of track 2 is track 1, and also the ancestor ID, which is number 1, the progeny ID, which is 2 and 3, it's labeled using binary, and the generation 1, the fate, which is division, and all these other parameters which we haven't filled in yet, which are customizable properties for the cell. So if we click on any one of these rows, you'll immediately see that cell highlighted in red with the pedigree structure. And that concludes how to track a cell.